This was number 4 from May 4th. So first off, they tell us that g is the integral from 0 to x of f. And then we want to figure out when g is concave up. So to figure out when g is concave up, we need to know when g double prime is greater than 0. If g double prime is greater than 0, we need to figure out that, first off, g prime is f. So g double prime is f prime. So if g is concave up, g double prime is positive, which means f prime is positive. So f prime is the slope of f. So when is the slope of this positive? From -4 to -2. And then it's negative from -2 to 0. Then it's still negative from 0 to 2. Then it's positive again from 2 to 6. Everybody good with part A? Any issues there? Part A was pretty straightforward. Part B gave us a new function, capital P of x, which was g, was it g of x times f of x? Yeah. We want to find p prime at 3. So first, let's write an expression for p prime of x. We'll do that using the product rule. So g of x, f prime of x, plus g prime of x, f of x. Everybody good with the expression for p prime? Evaluating at 3 gives us g of 3, f prime of 3, g prime of 3, f of 3. Yeah? What is g of 3? We'll go back here. G of 3 is just the integral from 0 to 3 of f. Which is the area underneath the curve from 0 to 3. We'll note that the area from 0 to 1 and the area from 1 to 2 are exactly the same, except one's positive and the other's negative. So those are going to cancel each other out. And then we've got minus whatever this piece is here. So what is that piece? That's a trapezoid. One base is 4. The other base is 3. Average of the bases times the height gives you g of 3 is -7/2. Everybody good with that? So g of 3. F prime of 3. F prime is the slope of f. And at 3, that slope appears to be
1.
That should be 1. And then now we need g prime of 3 and we need f of 3. Well, g prime is f. So g prime of 3 is actually the same thing as f of 3. So really, we've just got f of 3 times f of 3. F of 3 is negative. Let's do some arithmetic. -7/2 plus 9 gives us what? 11/2? Everybody good there? Yeah. Any questions on part B? Everyone's good. Part C. Part C. Find the limit as x approaches 2 of g of x over x squared minus 2x. What does that become? G of 2 over 0? What's g of 2? G of 2 is 0. We know that because, as we said a minute ago, those two areas between 0 and 1 and 2 cancel each other out. So we have 0 over 0, which means since this is the AP test right now, we're going to use L'Hopital's rule, and we're going to write out using L'Hopital's rule because that's what they want you to do on the AP test. They state that you're using it. This becomes the limit as x approaches 2 of prime over 2x minus 2, which ought to be g prime of 2, which we'll figure out in a second, over 2. And what is g prime of 2? That'd be f of 2, which is negative 4. Good or no? Looks good. Zoom, are you good?
Yes.
Great. Part D. Find the average rate of change of g on the interval negative 4 to 2. So g of 2 minus g of negative 4, it's just average rate of change, it's just slope, right? What was g of 2? We already knew that one, right? That was 0. We do need to figure out g of negative 4, though. So let's go back and figure out what g of negative 4 is. Well, that's the integral from 0 to negative 4 of that. Right? How do we do 0 to negative 4? We flip it and then do negative 4 to 0. So that's negative of, well, let's see, that's a triangle and a trapezoid. So let's do the triangle, 1/2 base times height, and then plus the trapezoid, which should be base 1 plus base 2 over 2, and then times the height. So what do we end up with there? 6 plus 10, 16, and then the opposite of that, so negative 16. So 0 minus negative 16 gives us 8/3. Everybody good with the first part there of part D? And then they say, does the mean value theorem guarantee a value C between negative 4 and 2 for which g prime of C is equal to this average rate of change? Well, theoretically, yes, but only if the initial conditions are met. Right? I mean, that's what the mean value theorem says, that the average rate of change equals the instantaneous rate of change if your function is what? Only if g is continuous and differentiable. We don't care about f and whether f is continuous or whether f is differentiable, because f is clearly not differentiable on the interval negative 4 to 2. Right? There's multiple corners. We care about is g continuous and differentiable on that interval. And is it? Yeah or no? Yeah? Why? The derivative of g is f. So does f exist at every point between negative 4 and 2? Yes. So does the derivative of g exist on that interval? Yes. So g is differentiable on that interval. And if a function is differentiable on an interval, that guarantees you that it must be continuous on that interval. So we can say that g is both continuous and differentiable on the interval because the derivative of g, f, exists on that interval. Therefore, it's continuous and differentiable. So yes, the mean value theorem says that the average rate of change of 8/3 must be equal to the derivative of g at some point on that interval. 8/3, which, 8/3 is like right there. Clearly, there's a point where it is. Good or no?
When we're doing the integral to find g negative 4, why do we switch the limits of integration and then add the negative? You have to?
Well, yeah, because you always want to go from left to right. Whenever you're accumulating area across a function, you always need to do it from the left to the right. So you got to have the smaller number.
Thank you.
Yep. Everybody good there?
Right, so is it kind of okay to just always flip it as a general rule? Like,
yeah, anytime you want to flip the limits of integration, you can.
Okay.
As long as you put a negative out in front of it. Yep.
Okay, cool.
Any other questions? You're talking specifically about part A or in general? Yeah, I mean, you're going to use parentheses anytime you're talking about concavity. 100% of the time, if you're talking about concavity, it's parentheses. If you're talking about increasing and decreasing intervals, you want to use brackets unless the endpoint is like infinity, so it's not really an endpoint. So then you still use a parenthesis. Or if the point, let's say let's say you're telling me that the function increases from 2 to 5, but 5 isn't actually included on the function. So you use a parenthesis for that. But if 5 is included, even if that's where it changes from increasing to decreasing, you'd still use a bracket. Does that make sense? Yeah. Yep. Yep. Concavity, always parentheses, 100% of the time. And then increasing, decreasing should be brackets unless it's at infinity, essentially. Other questions? Everyone's good? All right. Let's do the next one. How'd this one go? Good, bad?
I could do up to 5C. I got confused on 5D. Or like I didn't know what to do.
Uh-oh, that's not good. All right, part A, show that the derivative of this thing is this. That's pretty easy, I hope. Take the derivative of this with respect to x, so 4y dy dx, right, implicitly, minus 0, equals derivative of y sine x. We'll use the product rule, so y times the derivative of sine plus sine times the derivative of y. Everybody go with that? And then you just solve for dy dx. So 4y minus sine x on this side are both being multiplied by dy dx equals y cosine x. And then divide. Dy dx equals y cosine x over 4y minus sine x, which is exactly what they said it should be. That should have been pretty easy, I think. All right, part B. We want to write an equation for the tangent to the curve at 0, root 3. We need a point. We got the point. We need a slope. We can get the slope by using the derivative. So we'll just plug in 0 for x and root 3 for y. If x is 0 and root 3 is y, this ought to become root 3 times the cosine of 0. So that's just root 3 times 1 over 4 root 3 minus the sine of 0, which is just 0. So this just ends up being a slope of 1/4. Everybody go with that? Since they gave you a y-intercept, you can just write it as y equals 1/4 x plus root 3. Good? Any questions, Zoom? Everybody here seems like they're fine. All right. Part C. Find the coordinates of the point where the line tangent to the curve is horizontal. So if the tangent line is horizontal, what does that tell you about the derivative? Equals 0. And if the derivative equals 0, what? Say that again?
I was just saying it equals 0.
That's correct. Good job. All right. So if the derivative equals 0, I just need to make the numerator equal 0, right? That'll make the whole thing 0 as long as the same values don't make the denominator 0, but that's not something we're probably going to have to worry about here. So we'll plug in y cosine x equals 0. And we'll note that they gave us this information that y is always positive. So if y is always positive, what does that tell you? It doesn't matter that the y, right. That just tells you that just cosine x needs to be 0 because the y is just going to be some positive number. Right. So cosine x, if that's 0, well, that's at x equals pi over 2, right? So that's the x coordinate at which our function equals, or has a horizontal tangent line. We need to find the y coordinate. It said the coordinates of the point. So we'll go back to our original function, which was 2y squared minus 6 equals y times the sine of x. Is that right? I believe. And what's the sine of pi over 2? 1. So this is just y. So we got 2y squared minus 6 equals y, or 2y squared minus y minus 6 equals 0, or what is that factor 2? Put a 1 there. 2y plus 3 and y minus 2. Yeah. That gives us y equals negative 3/2 and y equals 2. But it says that y is greater than 0. So we'll ignore y equals negative 3/2 and just get y equals 2. So the coordinates of our point are pi over 2, comma 2. Good or no? Any questions or issues with that? Corey, okay? Okay. Tangent line on the I don't know. I don't know what do you mean? Okay. You sure you're good? Okay. All right, part D then. Part D says determine whether it's a relative min, max, or neither. So normally we do that with the sign chart, right? But the problem with the sign chart could potentially work. Actually, sign chart might work just fine because we know that y is always greater than 0. So one option is a sign chart. This is not actually how I did it during fourth period. But let's do a sign chart. If x is pi over 2, we're talking about the interval 0 to pi. And we know that y is always greater than 0. Let's see, what was our... yeah, that may not actually work. That's not actually going to work for us. Yeah, that won't work out because we're not going to be able to determine if 4y minus sine x is positive or negative. Yeah. So, we can determine if y cosine x is positive or negative, but we can't determine if 4y minus sine x is positive or negative just based on the information that y is greater than 0 and with a different x value. So this won't work. Which is why we will go ahead and use the second derivative test. All right, second derivative test says if at the first derivative it's 0, figure out the second derivative. If it's positive, it's a min. If it's negative, then it's a max. So we'll find our second derivative by taking the derivative of our derivative, which was what? What was the derivative? It was y cosine x over 4y minus sine x. Is that right? So we use the quotient rule for this. 4y minus sine x. Derivative of y cosine x is y times negative sine x plus dy dx times cosine x. So quotient rule with the product rule inside of it. Minus our y cosine x times the derivative of this, which is 4 dy dx minus cosine x. All over 4y minus sine x squared. Great. Isn't that wonderful? What a pain. What do we need to plug into it? We need to plug in 2 for x. No, sorry, pi over 2 for x, right? The pi over 2 comma 2 is the point, right? We need to plug in pi over 2 for x, and we need to plug in 2 for y. Do I need to replace all the dy dx's with y cosine x over 4y minus sine x? Yeah, good. We know that dy dx is equal to 0. So anytime I see a dy dx term, I can get rid of that. All the dy dx's is just 0. That's just 0, right? And what's the cosine of pi over 2? 0, right? So any of these cosines of pi over 2, all of those terms are just going to be 0 also. So really, I've gotten rid of more than half of what I've got to deal with here with this already. So now we've just got 4 times y, so that'd be 8, minus sine of pi over 2, that's 1. And then times 2, and then the negative sine of pi over 2, which should be -1. All over something positive, right? 8 minus 1 squared, so it's going to be positive no matter what. And we end up with what? -14 over 49, which is less than 0. And if the second derivative is negative, that tells you that the function is concave down, which tells you that it's going to have a max at pi over 2, 2. Everybody go with that? Any questions on that?
Wait, can you explain why we set dy dx to 0 again?
Yeah, because at this point that we're talking about, we had determined that the tangent line was horizontal, which meant that the derivative equaled 0.
Okay, thank you.
Yep. So if you tried to use the sign chart, right, you put on x equals pi over 2. We know that y is greater than 0, but our derivative was y cosine x over, what was it, 4y minus sine x? Is that right? Yeah. So we just, we know that if we plug in something, let's say here this is pi, and let's say this is 0. Let's say we plug in, I don't know, I mean, anything in the first quadrant, right? Anything in the first quadrant here, we're going to get a positive in the numerator. And then in the denominator, depending on what y is, 4y minus the sine of x. Well, sine of x in the first quadrant is positive, right? So this is 4 times y minus some number from 0 to 1. Right. So depending on what the value of y is, if y was, a quarter, or let's say y was like 1/100th, then this would be 4/100ths minus something between 0 and 1, which may or may not be positive. It might be positive, it might be negative. Does that make sense? So there's no way to determine if 4y minus sine x is positive or negative just based on the information that y is greater than 0. I mean, you could go back in if you had pi over 4 to your original thing and solve for y, but you don't have a calculator, and that's going to give you 2y squared minus 6 equals y root 2 over 2, which, I mean, you could theoretically, yes, you could go in and figure out what that is using the quadratic formula and get a really unpleasant value, but I feel like this would be easier. Yeah. I mean, you could probably, but it would suck. So. Good or no? Everybody good? People at home, you good?
Good, yeah.
All right. Let's do number 6. Five, whoever left. All right. Sketch the slope field through 0, 0. Looks like that. Follow the basic curve of the slopes. Should not go up above that horizontal asymptote. That's what it looks like. Everybody good with part A? Part A is pretty straightforward. Okay. Using correct units, interpret the statement, the limit as t approaches infinity of a of t equals 12 in the context of this problem. Well, what does that mean? First off, what does the limit as t approaches infinity of a function equaling 12 mean in the context of the function, not with the context of this problem, but just in terms of any function that has a limit as you approach infinity of 12, what does that mean? What?
Asymptote?
Yeah, it's a horizontal asymptote, right? It has a horizontal asymptote of y equals 12. Okay. Well, what is y? Y is A of t. What is A of t? A of t is the amount in milligrams of medication in the patient. So what is that telling us? That there is an upper bound on the amount of medication that the patient is going to have, right? That the most medication this patient's ever going to have in milligrams is what? 12? Max amount in milligrams of the medication is 12. Something to that effect would be. A and B of that one were really quick and easy. They gave you a lot of time to work through part C. Everybody good with A and B? All right. Part C, separate the variables. So we have dy over 12 minus y equals 1/3 dx. It was not dx, was it? It was dt. Darn. There was y though, right? Oh, good. All right, everybody good with the separation of the variables? Then we integrate. The right side is 1/3 t plus a constant. The left is the negative natural log of the absolute value of 12 minus y. Just doing a little simple u sub there on that. The initial condition says that when t is 0, y is 0. So we get negative ln 12 equals c. And then we get negative ln absolute value 12 minus y equals 1/3 t minus ln 12. We divide by the negative to get ln absolute value 12 minus y equals ln 12 minus 1/3 t. Then we exponentiate both sides. You get absolute value of 12 minus y equals 12 e to the negative 1/3 t. Then we clear off our absolute values and determine if we need the positive or the negative over here. So when we do that, we need to go back and think about our initial condition. When t is 0, what does the right side become? 12 e to the 0, or just 12. So that could either be a positive or a negative 12, depending on if we put the positive or the negative in. Over here, 12 minus the 0 should be 12. So we need 12 equals positive or negative 12. Well, that should be 12 equals positive 12, not 12 equals negative 12. So we're just going to leave this as 12e to the negative 1/3. And then we'll solve for y. We'll add the y over and subtract. So we get y equals 12 minus 12e to the negative 1/3 t. Good or no? Everyone's good there? Any questions on any of that one? Everyone's good? Zoom, you're good?
Yes.
Wonderful. I asked you guys to do 2 different rate ones, right? Is that right? We did the water one yesterday, right? Was it this other water one? The rainwater and the gravel. Anybody have a preference? Let's just do the rainwater one first, I guess. Yeah. Might as well, since it's the first one written here. Can you all see the problem at home? Did I share the screen right?
Oh yeah, we can see it.
Oh, wonderful. All right. So got rainwater flowing into a pipe. The pipe's partly blocked. The water is draining out. At the beginning, there's 30 cubic feet of water. We want to know how many cubic feet of rainwater flow into the pipe during the 8-hour time interval. That doesn't have anything to do with how much was in the pipe to start with, and that doesn't have anything to do with how much drains out of the pipe. Just how much flows into the pipe. So we integrate from 0 to 8 r of t dt. Your calculator told you that that was 76.57 what? 0 cubic feet. Good? Is that what other people got? Same value? Yeah? Yeah. Any questions on A? No? All right. Part B. We want to know, is the amount of water in the pipe increasing or decreasing at t equals 3? Well, the amount of water in the pipe. Is there a function for the amount of water in the pipe? Almost. 30, the initial amount, plus the integral from 0 to whatever t value we're interested in of r minus d. Everybody good with that being the amount of water in the pipe at any time? So we want to know if this thing, if this function is increasing or decreasing. How do you determine if a function is increasing or decreasing? Take its derivative. The derivative is r of t minus d of t. So we are interested in a prime of 3, r of 3 minus d of 3. If this number is positive, then that function is increasing. If that number is negative, then that function is decreasing. And what does that number come out to be? Negative 0. What? 314. People agree with that? Yeah? Yeah. Therefore, it is decreasing. Everybody good with part B? Zoom people, you good with part B?
So I did the same process, but I didn't actually write I didn't write that equation, but I put in a 3 for the increase or for the water gained and water lost. And I just subtracted them and showed that. That's fine.
That's totally fine. You're going to need for part C this equation that we did.
Yeah, I eventually got it, but for
Yeah,
part
yeah.
B, I didn't put it. Okay.
That's
thanks.
fine. If you didn't write it in part B, that's not a problem. All right, part C, we want to know at what time is the amount of water in the pipe at a minimum. So we're looking for when is A at a minimum. So that's when is A prime equal to 0. Okay, so A prime or R minus D equals 0. You can either graph R minus D and see when it has an x-intercept, or you can graph R and graph D and see where they intersect with each other. Either one is fine. What t values did that occur at? .272. That's the only one. Yeah. Is that the only one? I didn't pull up the scoring guidelines, so I can. Is that the only one you guys got? Yeah. And then you also need to check the endpoint. So we're also going to check t equals 0 and t equals 8. So we'll now use that amount of water function that we wrote in part B, or you'll write it if you didn't write it for part C, if you didn't write it for part B, and just plug in 0, which gives you 30. You plug in 8, which gives you some value, and you'll plug in the critical value that you got. And just make a little chart. So we'll say T and then the total amount. At 0, it was 30. What did you get at 3.272? Nobody?
Like 27.96.
That sound accurate to other people? Or no? Be nice to have confirmation from one other person. You didn't get that far. All right, what about 8? What'd you get at 8? Probably something more than that.
48.54.
And let's always round to 3 decimals. 48.5 for what?
I didn't write that down.
All right.
Okay. Sorry.
That's all right. All right, we're gonna have to look at the scoring guidelines here. So I can get my 3rd decimal. What was this problem about rainwater? All right. Looks like 27.965 and 48.544. And so our absolute minimum was one of those that was the smallest, which was this, 27.96. And it said, at what time is the amount at a minimum? So we would say at t equals 3.272. Everybody good with that for part C? All right. Part D says the pipe can hold 50 cubic feet of water before overflowing. When we're greater than 8, the water continues to flow in and out at the same rates until it starts to overflow. We want to write, but we don't need to solve an equation involving one or more integrals that gives the time when the pipe will begin to overflow. Okay, so time is going to be W. So we need to figure out when 30 plus the integral from 0 to W of R minus D, we should probably write it out as R of T minus D of T, is equal to 50. And you don't need to solve it, so you don't need to worry about it. That's it. Good or no? Any questions on part D? Yeah, there were 2 points. Exciting. One for having the integral itself and one for the whole expression. Yeah. All right. Yeah. It depends. So this specific question says at what time is it at a minimum? So you need to find, your final answer should be the time at which it's at a minimum. Yeah, yeah, exactly. This is your justification. You found the critical value, you checked the endpoints, and the lowest one was at 3.272. Yep. All right, how did the gravel problem go? Better or worse than the rain? Did you guys actually do it? Half the people here have shaken their heads no at me. Jake did the problem. Thank you, Jake. Did you people at home actually do this problem? Should I give you guys a few minutes to try and do it on your own, since most of you are slackers? Nobody told you, Josh. Wow. Wow.
I was taking my Lang exam, okay? I didn't know.
I was chastising the other people for not telling you. Yes, Samantha, you did it on May 4th. Did you do it? You didn't do this. You did not do the gravel problem on May 4th. You did not do the gravel problem on May 4th. That is not true. You did the other ones that we were doing on May 4th, but not this one. Psych. Psych. We're like back to the 90s now. That's what? She's 30 years old internally. Okay. Tom says you're 30. 30 years old. Yes, Tom did say that. Yes, that was Tom. He says, internally, you are 30 years old. She's 7. All right, I'm gonna give you guys a couple minutes to do the gravel problem, I guess. Jake, you can like relax, take a nap, do some other problem if you want. Oh. Well, you can spend some time thinking about it or ask me a question about it. All right, do this gravel problem since so many of you didn't. G prime of 5, what was G prime of 5? And using correct units, interpret your answer in the context of the problem. So this is the derivative of G. G was what? The rate in tons per hour. And so T is in hours. So this is tons per hour or tons per hour squared. Yeah, you did. So tons per hour squared. And we would say that the rate at which the gravel arrives is decreasing. Right? Not that the amount of gravel that arrives is decreasing, but the rate is decreasing because we took the derivative of the rate function. Okay. Part B, find the total amount of unprocessed gravel that arrives. Doesn't matter how much there was to start. Doesn't matter how much is processed. All we care about is how much arrives. That's an integral from 0 to 8 of G of T, which came out to be 825.551 tons of gravel. Doesn't say you need units that time, so you don't need units. Yeah, I mean, they like to do a regular work day for things. I don't know. Sometimes they do 0 to 12. Sometimes they do 0 to 60 when you're measuring rainfall in Stormville. All right. Oh, I just duplicated that page, didn't I? I don't need 2 of those. All right. Part C. Is the amount of unprocessed gravel at the plant increasing or decreasing at T equals 5? So once again, you don't need to for part C, but I like to write out the equation. The amount of gravel is 500 plus the integral from 0 to T of the amount that arrives minus the amount that is processed. And how much is processed? 100 tons per hour. So 100 times the time period. If you wanted to, you could write this as minus the integral from 0 to T of 100 dt, right? But what's the integral of 100? It's 100 T. Right, so either way you did it is fine. I prefer to write like this. So we want to know, I forgot what we're trying to find. Is the amount increasing or decreasing? So this is the amount. We want to know if A prime of 5 is positive or negative. A prime of 5 ought to just be G of 5 minus 100. Derivative of 500 is 0. Derivative of 100t is 100. Derivative of the integral from a constant to t of G of t is G. So G of 5 minus 100. What did that come out to be? Positive or negative? Or what, what's that?
I got negative 1.859.
That sound good to people? Less than 0, so decreasing. Then for part D, it says, what is the maximum amount of unprocessed gravel at the plant during the hours of operation? So we want to know, when is this function at a max? Well, we take its derivative. The derivative is G of t minus 100 and set that equal to 0. Right? Just like we did with the rain problem in the previous one. Set the rate equal to 0. And what t value did that give us? Anybody got a t value? 4.923. And so then we just plug that You know, we plug in our t values and our a values at the endpoints, 0, and 8, and then we plug in 4.923 into this, and we evaluate each of those three things and see what you get. The first one is 500. And what did the last one come out to be? The last one should have been 500 plus that first value we got from B minus 800. What did that come out to be for 8? Now, we already did the integral from 0 to 8 of g, right?
It's like 525.551.
525.551. Okay. And then what was the value at 4.923 when you plugged that in?
I got 635.376.
And so the value at 4.923 is the max. And it asks, what is the maximum amount? So this time it's asking for the y value. So we would say 635.376 tons. And your justification is you found the critical value and you tested that and the endpoints in a chart, or somehow showed each of those values to show that that one was the largest. Writing, no, having it there is fine. Writing it out is not necessary. Any questions on that? You found the derivative of g of t minus 100t? No, that's not right. You need to find the derivative of the amount equation. You have to set the rate in minus the rate out equal to, or well, the rate in minus the rate out is the derivative of the amount. So if you took the derivative of g, that's not correct. People in Zoom, you're good to go unless you have questions. If you have questions, hang around.